Coming to the question number 1. Two circles of radii 5 cm and 3 cm intersect at 2 points and the distance between their centers is 4 cm. Find the length of common chord. Now moving on to the solution. Let us consider two circles intersecting at 2 points. Let us consider two circles as shown in figure which are intersecting at 2 points. Let those points be A and B. Let centers of circles be O and O dash. Here he has given the distance between their centers, that is O dash is equal to 4 centimeters. And the radius is given as 5 centimeters and 3 centimeters of each circle respectively, that is OA will be equal to 5 centimeters, OA will be equal to 5 centimeters and OA dash will be equal to 3 centimeters. Let us join OA and O dash A. Now OA square is equal to 5 square, which is nothing but 25, and also O dash square plus O dash A square is nothing but 3 square plus 4 square, that is 25. Therefore here O dash A is a right triangle. Therefore we can say that O dash is right angle triangle. And now let us join AB. That will be the common chord. We know that the line joining centers of circles perpendicularly bisects the common chord of the two circles. Therefore we can say that O dash will be perpendicular to AB and the length of the chord will be equal to 2 times the line joining centers, that is equal to 2 times O dash is nothing but 4 centimeters. Therefore we get AB is equal to 8 centimeters, that is length of common chord is equal to 8 centimeters. Coming to the second question. If two equal chords of circle intersect within the circle, prove that segments of chord are equal to corresponding segments of other chord. Now moving on to the solution. Let us consider a circle as shown in figure. Let the circle be with the center O, and here AB and CD be chords of equal length that intersect at point M. Therefore here in the solution AB and CD are chords such that AB is equal to CD, and here AB and CD will intersect at point M. Now let us draw a perpendicular OE to the chord AB and perpendicular OF to the chord CD. That is, we have drawn here OE perpendicular to AB and OF perpendicular to CD. Let us join OM. Now here, if we observe in triangle OME and triangle OMF, angle OEM is equal to angle OFM is equal to 90 degrees since we have drawn the perpendiculars, and OM is equal to OM, which will be the common side for both triangles, and the perpendiculars drawn from center to the equal chords will be of equal lengths. Therefore we can say that OE is equal to OF. Therefore here by property of RHS congruency we can say that both the triangles are congruent. That is, triangle OME is congruent to triangle OMF. Here we got that two triangles are congruent. Therefore we know that when two triangles are congruent, then their corresponding sides can be equated. Here let us equate the corresponding sides, that is ME is equal to MF. That implies Instead of ME, we can write EB minus MB or BM. That is equal to, instead of MF, we can write here DF minus MD. But we know that the lines perpendicular to the chords from the center always bisect the chord. Therefore, we can say that EB is equal to half AB and DF is equal to half CD. Let us substitute in the above equation, then we get half AB minus BM is equal to half CD minus MD. But we know that AB is equal to CD since we have taken the equal chords. Therefore, half AB will be cancelled on both sides. We are left with minus BM is equal to minus MD, which implies BM is equal to MD. This is the first thing, that half of the segments from the intersection point are equal. Next, we need to prove that other segments, that is AM is equal to CM. In order to do this, let us consider that EM is equal to MF. That implies, let us add half AB on both sides. Then we get half AB plus EM is equal to MF plus half AB. That implies half AB plus EM is equal to MF plus half AB can be written as CD. That implies, here instead of half AB, we can write the value as AE, since AE is equal to half AB plus EM is equal to MF plus half CD can be written as FC. Therefore, now again from figure we get AE plus EM is equal to AM and MF plus FC is CM. Therefore, here we got AM is equal to CM. Now, by the result 1 and 2, we can say that if the two equal chords of a circle intersect within the circle, the segments of one chord will be equal to corresponding segments of other chord. Moving on to question number 3. If two equal chords of circle intersect within the circle, prove that the line joining point of intersection to the center makes equal angles with the chords. Now moving on to the solution. Let us consider a circle with two equal chords in it. So in the solution, we have considered a circle with center O and two equal chords, that is AB and CD, of equal lengths intersecting at point E. Therefore, here given that AB and CD are two equal chords, and here, so we can write that AB is equal to CD. We are required to prove that line joining the point of intersection, that is E, to the center divides equal angles with the chords, that is angle OEC must be equal to angle OEA. This we need to prove. Now, in order to prove that, let us draw perpendicular OP to the AB chord and perpendicular OQ to the CD chord. Therefore, here we have drawn OP perpendicular to AB and OQ perpendicular to CD. Now, let us consider in both the triangles, that is triangle OEP and triangle OEQ. Now let us consider in triangles OEP and in triangle OUQ. Angle OPE is equal to angle OQE is equal to 90 degrees, and here OE is equal to OE since it is a common side and also hypotenuse, and we know that chords of equal length or equal distance from the center, we can say here OP is equal to OQ. Therefore, by RHS property of congruency, since it is a right angle triangle, we can say both the triangles are congruent. Therefore, triangle OEP is congruent to triangle OEQ. We know that when two triangles are congruent, then their corresponding angles and corresponding sides will be equal. So here we can equate angle OEP is equal to angle OEQ. This is what the required proof for us. That implies this can be further written as angle OEA is equal to angle OEC. So this is what the required proof for us, and it is hence proved. Moving on to question number 4. If a line intersects two concentric circles, that is circles with same center, with center O at A, B, C and D, prove that AB is equal to CD. Now moving on to the solution. Here he has given that there are two concentric circles with the same center O, and A, B, C and D are the points lying on them as shown in figure. Now he asks us to prove that AB is equal to CD. Therefore here we are required to prove that AB is equal to CD. In order to do this, firstly draw OM perpendicular to AD. Now in the first concentric circle, let us consider that OM is perpendicular to BC. Then we know that the line from center to chord drawn perpendicularly bisects the chord. Therefore here we can say that BM is equal to MC. Let it be as equation number 1. Similarly, if we consider that OM is perpendicular to AD, then we can say that OM is perpendicular to AD and it divides the segment AD into two equal halves, that is AM is equal to MD. Let it be as equation number 2. Now let us consider 2 minus 1, which implies AM minus BM is equal to MD minus MC. That implies AM minus BM is nothing but the segment AB is equal to MD minus MC is nothing but the segment CD. Therefore this is what the required proof for us, that is AB is equal to CD, and it is hence proved. Moving on to the 5th question. 3 girls, Reshma, Salma and Mandeep, are playing a game by standing on the circle of radius 5 meters drawn in a park. Reshma throws a ball to Salma, Salma throws to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep? Now moving on to the solution. Let us consider a circular park as shown in figure. Let its center be at O, and here let the Reshma be represented as R on the circle, the park, and Salma be represented by S on the circular park, and Mandeep be represented as M on the circular park. Now he has given that distance between Reshma and Salma and Mandip is 6 meters each. That is, MS is 6 meters and RS is also 6 meters. And he has given the radius of circle as, and he has given the radius of the park as 5 meters. Therefore here OR and OM will be equal to 5 meters since they form the radii of the circle. Now let us join MR and also OS. So here we need to join MR and OS. Let the point of intersection be some M. Let the point of intersection be some P. Now we need to find the distance between RM. That is, RM is equal to what? Let us assume that in order to prove that, let us assume OP is equal to X. Then PS becomes OS minus OP, which is equal to, OS is nothing but radius phi minus OP is X. And here we have given the dimensions that OR is equal to 5 meters, OM is equal to 5 meters, and RS is equal to 6 meters, and MS or SM is equal to 6 meters. Here also we assume that OP is X and we got PS is equal to 5 minus X. Now let us consider in triangles, triangle OPX and triangle OPM, OR is equal to OM, which is given as 5 meters each according to problem, and OP is equal to OP, which will be the common sides for both the triangles. Angle ROP is equal to angle POM, since the equal chords MS and RS subtend the equal angles at the center. Since the chord RS is equal to chord SM, the angle formed here, that is POM and POR, will be formed by the arcs of same length. Therefore the angles will be equal. Now by property of Sas congruency, therefore by Sas property of congruency we can say that here triangle OPR is congruent to triangle OPM. When two triangles are congruent, then their corresponding angles and corresponding sides will be equal. Therefore here we can say that angle OPR will be equal to angle OPM. But also, if we observe the figure clearly, we can say that angle OPR and angle OPM form the linear pair. Therefore we can say that sum of angles that forming a linear pair is equal to 180 degrees. Angle OPR plus angle OPM is equal to 180 degrees since they form the linear pair. That implies instead of angle OPM we can place here angle OPR, that is equal to 180 degrees, which implies 2 times angle OPR is equal to 180 degrees, which implies angle OPR is nothing but 180 by 2, that is nothing but 90 degrees. Therefore we can say that triangle OPR is a right triangle. In right triangle, by Pythagoras theorem, in triangle OPR, by Pythagoras theorem we get OR square is equal to OP square plus PR square. That implies OR is nothing but 5 square, that is equal to OP square here is X square plus PR square. That implies PR square is equal to 5 square minus X square. Let it be as equation number 1. Similarly, if we consider both the triangles RSP and PSM, in these both triangles we get RS is equal to SM, since which is given as 6 meters each, and PS is equal to PS, that is common side for both the triangles. And also here angle subtended by the OM at this point S will be equal to angle subtended by OR at this point, since they are the radii of the circle. Angle PSR is equal to angle PSM. Now by SAS property of congruency we can say both the triangles are congruent, that is triangle RSP is congruent to triangle MSP. We know that when two triangles are congruent, then their corresponding sides and corresponding angles can be equated. Therefore here angle RPS will be equal to angle SPM. But if we observe the figure clearly, we can say that both the angles also form the linear pair. Therefore angle RPS plus angle SPM is equal to 180 degrees, as we know that sum of angles that form linear pair is equal to 180 degrees, which implies 2 times angle RPS is equal to 180 degrees, since here we can replace angle SPM by RPS, that is angle RPS is equal to 180 degrees by 2, that is 90 degrees. Therefore we can say that here angle RPS is equal to angle SPM is equal to 90 degrees. Now let us consider in the right triangle RPS. By applying Pythagoras theorem we get hypotenuse square, that is RS square, is equal to side square, that is PS square, plus other side is RP square. That implies RS square is nothing but 6 square, which is equal to PS square is nothing but 5 minus x whole square, plus RP square, let it remain as it is. That implies here we get RP square is equal to 6 square minus 5 minus x whole square. Let it be as equation number 2. Now considering 1 and 2, we got PR square or RP square on left hand side is equal. Therefore here we can equate the right hand side, that is from 1 and 2. 5 square minus x square is equal to 6 square minus 5 minus x whole square. Now let us expand this, then we get 5 square, that is 25, minus x square is nothing but, let it be as it is, which is equal to 6 square is nothing but 36 minus of 5 minus x whole square. Let us apply the a minus b whole square formula, that is a square 25 plus b square, that is plus x square, minus 2ab, that is minus 2 times 5 times x is nothing but 10x. That implies 25 minus x square is equal to 36 minus 25 plus x square minus plus x square plus 10x. That implies 25 minus x square is equal to 11 minus x square plus 10x. That implies, let us take this 10x to left hand side and send this 25 minus x square to right hand side, then we get 11 minus x square. Here we get minus 10x is equal to 11 minus x square minus 25 plus x square. Here plus x square and minus x square will be cancelled. That implies minus 10x is equal to minus 14. That implies x is equal to 14 by 10, that is 1.4. Therefore we got x is equal to 1.4. Now by considering the figure, we got OP is equal to 1.4 centimeters and PS is equal to 5 minus 1.4, that is, so here we can say that we got OP is equal to 1.4 centimeters and PS is equal to 5 minus 1.4, that is 3.6 meters. Let us find the length of RN first. Let us find the length of RP and PM. We know that RP square is equal to 5 square minus x square, which is equal to 5 square is 25 minus 1.4 whole square is 1.96, that is equal to 23.04, which implies RP is equal to square root of 23.04, which is 4.8. Since here we got that RP is equal to 4.8, as the two triangles are congruent, we can say PM also equal to 4.8. Now we need the distance between Mandeep and Reshma, therefore we get which is equal to RP plus PM, that is 4.8 plus 4.8 is 9.6 meters. Therefore the distance between Reshma and Mandeep is 9.6 meters. Moving to a sixth question. A circular park of radius 20 meters is situated in a colony. Three boys, Ankur, Shayet and David, are sitting at the equal distance on its boundary, each having a toy telephone in his hands to talk each other. Find the length of the string of each phone. Now moving on to the solution. Let us consider a circular park as shown in figure. Let us assume that boy Ankur represented by A on the circle and boy Shayet is represented on the other side of the circle and boy David is represented by D on the circle, are standing at the equal distance on the boundary of the circular park. Let the center of the circular park be. He asked what is the length of string of each phone. Therefore here he has given that radius of the circular park is 20 meters. We know that as they are standing at the equal lengths on the boundary, we can say that arc AS is equal to arc SD is equal to arc DA. Since they are standing at the equal distance and the string is attached between the telephones, that will be of equal arc length. We know that sum of all the arc, that is perimeter, is equal to sum of arc AS length plus arc length of SD plus arc length of DA. That implies we know that perimeter of the circular path is nothing but 2 pi r, where r is the radius, is equal to, instead of arc AS, arc SD and arc DA, we can write 3 times arc AS, any one arc, that is arc AS, which implies arc length of AS is equal to 2 pi r by 3, that is equal to 2 into 3.14 into radius is given as 20 here divided by 3, that is equal to 2 times 3.14 times 20 divided by 3 is 4.186 meters. Therefore here we can say the length of the string, that is length of each string, is equal to the length of arc formed by one of the telephone connection between two of them, that is AS or SD or AD, which is nothing but all are equal here, that is 4.186 meters.